If x of t gives us a Fourier transform pair of x of j omega, then from the inverse transform equation or the synthesis equation, we can write x of t to be equal to 1 over twice pi minus infinity to infinity x of j omega e to the power minus j omega t d omega. Now, if we replacing t and omega interchangeably, that means in this equation we are to replace omega instead of t and t instead of omega. This will give us the value x of t becomes x of omega, 1 over twice pi remains as it is, minus infinity to infinity is the integral limit. X of j omega becomes x of j t e to the power minus j. Omega is replaced by t and t is replaced by omega, so it remains as it is. D omega becomes d of t. Upon cross multiplication, we can write twice pi, taking this twice pi in the left hand side, x of omega to be equal to minus infinity to infinity x of jt e to the power minus j omega t dt. Now then, if we look upon the, what will I say, the synthesis equation, that is x of t, which goes from minus infinity to infinity x of f e to the power j omega t minus j omega t df. I'm sorry, not this one. If we look at the analysis equation, what I meant to say is that x of j omega, which is equal to x of t e to the power minus j omega t dt minus infinity to infinity, it is quite similar to this value, where instead of small x of t, we get it as capital X of jt, and the rest is as it is. So this can be written as capital X of, instead of j omega, we can write it as capital X of t. So capital X of t will give us a Fourier transform of twice pi x of negative omega. I'm sorry, ladies and gentlemen, there seems to be a mistake where we have, let's see the duality property once again. Let's see it once again. Duality property. Where if x of t gives us a Fourier transform pair of x of j omega, then we can write x of t from the inverse transform equation to be equal to 1 over pi x of j omega e to the power minus j omega t d omega minus infinity to infinity. As I have said earlier, we are replacing t with omega and omega with t. This will give us x of omega 1 over twice pi minus infinity to infinity x of jt e to the power j omega t dt. This will be plus. Now replacing the value of omega with negative omega, what we get, x of minus omega 1 over twice pi minus infinity. I have skipped this step in the previous term. Minus infinity to infinity x of jt e to the power minus j, since omega is replaced by negative of omega, dt. And as I've said earlier, this value will be equal to x of t. So the duality property essentially states that x of t will give us a Fourier transform pair of twice pi x of minus omega. Now we come to the last but not the least property, which is the Parseval's theorem. Which states that the power density spectrum of the signal, of any aperiodic signal, will be an energy signal and is mathematically written as minus infinity to infinity x of t squared dt will be equal to twice pi minus infinity to infinity x of j omega d omega. Now let us solve this. From the left hand side, we get minus infinity to infinity x of t squared dt can be written as minus infinity to infinity. This can be written as x of t times x conjugate of t dt. Now then, since x of t is equal to 1 over twice pi minus infinity to infinity x of j omega e to the power j omega t dt, so x conjugate of t will be equal to 1 over twice pi, which goes from negative infinity to infinity, x conjugate of j omega e to the power minus j omega t dt. I mean d omega. This value is omega. So replacing the value of the conjugate, that means this part, with the inverse transform equation stated over here, we get minus infinity to infinity x of t times 1 over twice pi minus infinity to infinity x conjugate j omega e to the power minus j omega t dt and d omega. Now rearranging a bit and write minus infinity to infinity, taking this part outside the integral, x j omega is infinity to infinity x of t e to the power minus j omega t dt d omega. Now upon closer inspection, this part of the equation is nothing but x of j omega. So we can write minus infinity to infinity x conjugate of j omega times this part can be summarized to x of j omega, and d omega remains as it is. Now similarly, if we can, dissolving this part, we can get an expression as this. So multiplying these two, we can get minus infinity to infinity x of j omega squared d omega, which is equal to the right hand side, and this is known as the power spectral density of the, otherwise the Parseval's theorem for continuous time Fourier transform for aperiodic signal. With that, we come to the end of the property analysis of the continuous time Fourier transform, and in the next part of the lecture we shall focus upon the mathematical problems or the analytical problems for that may appear in the exam.